Hello friends, welcome to my YouTube channel. Due to some personal reason, I have been uploading video for a long time, so sorry for that. This video is for suspension design. Many have mailed me to know how to design suspension from scratch. So this video deals with those topics. So what is designing? Many engineers have a lot of definitions and a lot of different perception of designing. For me, designing is a process to find dimensions from scratch or from nothing. Okay, see, what is the work of a design engineer? The work of a design engineer is to release drawing. And how will it release drawing? It will release drawing by knowing the dimensions. And how will it know the dimensions? The process to know dimension for me is designing. Okay, so for knowing designing, it's very important to know three things. First thing is what a dimension is required. Like suppose I have to design a cube, so three dimensions are required. So unless and until I know that how many dimensions are required, I'll not be able to design. And the second most important thing is importance of those dimensions. Whether increasing or decreasing dimensions will improve or deteriorate my design quality. This is very important. Unless and until you know the effect of dimensions on your design parameters, you will not be able to design it. And the third very important point is what your competitors are doing, or what in your case other teams are doing. Sorry, this is very important. There are sorry, there are several things, like caster, camber, KPI, which there is no hard and fast rule that you should take this. So it's very good to keep an eye on your competitor, what values they are choosing. Okay, it helps you in taking decisions. So so the basis of suspension design is line diagram. I hope all of you know the line diagram. If you don't know, then you can look to my previous videos. I'll just give a refresher of it. See, below is the cut section of a car. Okay, and the if you join everything with a line, like if you join the upper ball joint to the lower ball joint with a line, if you represent the whole wheel with a center line, if you join the chassis mounts and the upper ball joint with a line, and similarly for the lower wishbone, you will get a line diagram. Sorry, you will get a line diagram. This line diagram is very important. This line diagram helps me to know the kinematic properties of the uh, suspension system. Okay, and again uh, for drawing line diagram, what do you need? You need the dimensions, and let's discuss how to find those dimensions. So first I'll discuss about the dimension which is denoted by A, which is the wheel length. So you'll purchase wheel. You definitely not fabricate wheel, you'll purchase the wheel. So suppose I decided that I want to purchase wheel with some dimensions like sorry, R30 165 by 65, something like that. So by using this, I can calculate what is the height of the wheel at the maximum inflated position. Okay, and we'll go with that. Okay, because you design for endurance, and before endurance they give you an option of optimizing your air pressure inside the tire. So maximum inflated position is good enough for you. So that is how you will get your dimension A. And the next dimensions which I want to discuss is B, which is the line joining the upper ball joint and the lower ball joint. Now for knowing B, you should know scrub radius. Scrub radius is a very important thing. Now what is scrub radius? if you project this line down, sorry, if you project this line down, so the distance between the wheel center point, this point, and this projection is your scrub radius. Now if this scrub radius is too low, what will happen? Driver will not get the feel of the road, but a driver will not get the right input, right feedback from the road. And if this is too big, the driver will have to apply a lot of torque uh, to turn the wheel. Okay, so there should be a optimum scrub radius. Again, what values to use? So I will not tell you any value. I want you all to look for the design uh, presentations of other team, and after 10-12 design presentation you will come to know what scrub radius to use. We also did the same thing. So because there is no hard fast rule that this should match scrub radius. Okay, so this is the thing. The next thing is that see, inside the rim you have space. Now you should not utilize the whole space. What I mean that you should consider serviceability also. Like if you're designing knuckle, and if it's too big, it's almost touching the rim, then it will be very difficult for you to change camber and do everything. So you should have some gap between the rim and the knuckle, such that you will feel comfortable in operating with it. Okay, so consider that also. And once you decided your scrub radius, then KPI is also very important, and KPI and scrub radius works very similarly. Now again, for that also, what I suggest is to go to the internet and read design presentation of other teams and come with the value, because there is no hard fast rule that this should be my KPI value, key inclination value. Okay, now uh, the lower wishbone length and upper wishbone length. See, the lower wishbone length and upper wishbone length depends on instantaneous center and roll center, but you need to iterate with different combinations and come up with a best possible combinations of the lower wishbone and upper wishbone length. So those iteration will involve altering the length of the wishbone, or changing the instantaneous center or the roll center, any uh, way of iteration that you can follow, but you have to come up with a best possible combination. And just one more thing, that once you get your base iteration, then prepare a model with wires or PVC pipes, and get the feedback from your driver. If your driver says that it's too uh, what to say, uh, it's not comfortable, it's too uncomfortable, and then you have to alter your design, because you are designing for the driver. If your driver is feeling very uncomfortable, then it's no use of proceeding with that design. So whatever you design, and this thing is for chassis team also, whatever you design, you prepare a prototype and get the feedback of the driver. It's very important. Okay, so we'll proceed further. So what is instantaneous center? So instantaneous center is a point on a member about which the whole system rotates. Okay, and roll center is also very similar thing. Okay, and why this name instantaneous center? Because at that particular instant, this is the point of rotation. At some other instant, or at some other time, the point of rotation can change. Okay, so this is the instantaneous center. Now for example, I have drawn a rod which is pivoted at one end, and a force F is applied on the other. Now with the application of force, it will show some angular deflections. Now I'll say that I have another rod, okay, with greater length, okay, L dash, and same F force is applied, and it's pivoted at one end. Okay, so um, it will also show angular deflection, but uh, its angular deflection will be less. Okay, can you understand why? See, my torque is equal to I alpha. Now my torque with the increase of length has increased. My inertia is also increased because of increase in length, and inertia has term of L square. So increase in inertia will be more. So my angular deflection will decrease. Now this is very important. This means that if you increase the distance between the point of application of force and the point of rotation, then your angular deflection decreases. Now why this is important, we'll discuss further. Now what is the importance of an instantaneous center? Now for that we need to understand why we design suspension. So we design suspensions to maintain wheel in upright position in almost all possible time. Okay, so it's not possible to maintain every time, but our aim is that. So in other words, we can say that the change in the angular position with respect to a reference point should be as minimum as possible, should be minimum, as less as possible. So from the previous example we can conclude that if we um, increase the distance between the IC and the point of application of force, then we can achieve this achieve this minimization of angular position, minimization of change in angular position. Okay, so this is very important thing. Now for Roll Center, this is a extract from Hensler Hesra. This is a very good book and I recommend all of you to read that. So the gist of this extract is that if the Roll Center is very close to CG, then overturning couple will be very less and it will be not give a right feedback to the driver. But if the distance between CG and Roll Center is too high, then again it will have a too big overturning couple, and again it's not good for the driver. So it should be optimum. Again you'll ask what should be my Roll Center value. Again I'll say the same thing. You should go with the benchmarking approach to get the exact Roll Center values, because there is no exact match. One more thing, that whenever you are designing your Roll Center and the front Roll Center, then consider the weight distribution also. Do the weight distribution calculation. This front Roll Center and the rear Roll Center determines your weight distribution at the time of cornering in the front and the rear. Okay, and the formula is R in Thomas de Gillespie also, and RCVD, and whatever book you are reading, they will have formula. Just ensure that everything is right by applying this weight distribution formula. Why I say that you should apply weight distribution thing? Because suppose in the uh, in the when the car is translating, or when the car is moving the straight line, the weight distribution is suppose 60-40, sorry, 60 in the rear and 40 in the front. Now at the time of cornering, if some drastic change in this weight distribution happens, then it's not good. Okay, so by doing the weight calculation you will ensure that no drastic change has happened. So it's a good habit to do. And moreover, the as your rear has more weight, your rear Roll Centers can be a bit higher than your front Roll Center. This is important. And CG is very problematic thing. See, we do not have a exact model, so it's very tough to calculate CG. So what I did, I assumed CG between driver and engine, because they are the most heavy part of the vehicle. So between the driver and engine, I assumed one CG and then I continued with it. Okay, so if you have one previous car, then you can probably calculate CG. But if you are designing it first time, then calculation of CG is very tough. Okay, so now we read about the IC and roll center and everything. Now, one thing is very clear to you, that you need to iterate. There is no exact solution of it. Now, for iterating, there has to be a evaluation criteria. So, what should be my evaluation criteria? So, the just look at this diagram. The first diagram is of roll, and the below diagram is of bump. Okay. So, what does roll means? Rolls means the whole system will rotate about a point, roll center. And what this bump means, as you can see, the chassis will translate up. So remember that race cars are designed for roll conditions. Your aim is that in roll, the uh, change in angular position of wheel should be minimum, or mm, change in camber should be minimum. So this is uh, this is very important. Why it should be minimum? Because if at the time of cornering your wheel is upright, sorry, at the time of cornering, if your wheel is upright, then you will get more traction and you can get edge over your competitors at the time of cornering. So it's very important. Now, at the time of cornering, your inner wheel will have a negative camber, while your outer wheel will have a positive camber. Okay, now I'll take a scenario that your outer wheel changes from 0 degree to plus 2 degree. Okay, now if I give initially minus 2 degree, then at the time of cornering it will change to 0 degree, and the moment it changes to 0 degree, that means it will have a maximum traction, and it will have a greater cornering force and greater cornering ability. Really sorry. So this is again very important. Okay, the choice of initial camber can give you an edge over your competitors. Okay, so this is very important. So I just summarize it. What is your evaluation criteria? If your evaluation criteria is that you have to choose such dimensions which minimizes your change in camber position in the roll condition. Okay, now many ask me about the softwares to use, so I just give you one example. Where SolidWorks? Okay, so I have created this model. Okay, so what I did, I have ensured the dimensions of everything, and I have constrained this point with this line. I have assumed this as a ground. Okay, now what can I do? I can rotate this. I can rotate this with the center. Suppose this is my roll center. I can rotate this by 5, 6, 7, 8, but whatever degree I want to know, and I can note the camber. So I don't need a software, extensive Lotus or anything for doing that. By doing these all rotations and playing with the CAD only, I can know the what camber changes this iteration is bringing. Okay, so even if you don't have any software, don't be disheartened. This can be done in CAD also. Now, one more important thing. Hmm. This is one of the papers, and this is one of the most beautiful paper that you will ever read on FSAE. Okay, they have iterated for everything. Like they have iterated for equal and parallel arms, unequal and parallel arms, unequal and non-parallel arms, unequal and non-parallel lower rolls, and they have iterated with everything. Okay, and they have found out the camber change. Whichever camber change is minimum, they have selected that. Okay, This is a very good paper, and I think you should read it. I'll put the link in the description box. If I forget, then you can remind me in the comment section. Okay, that's it from my side. And in conclusion of everything I just tell you, that have patience, iterate as much as possible, and check for change in camber in the raw condition. If you feel that your dimension is okay, then check with the fabricators also that this can be designed or not. This is very important. Okay, check with your fabricator. See, something which you design, if it can't be fabricated, then it's of no use. Okay, and at the time of fabrication you will face a lot of problems. So it's a very good habit of discussing with your fabricators beforehand, before designing, that whether or not you will be able to fabricate this. Okay. Okay, that's it. With that, I'll just end this.